Greetings, physics lab patron. This is a video that is intended to walk you through how to complete the first in many online physics labs at American University. The files that you will need open to complete these labs include the Spreadsheet Basics lab manual. It's a PDF. You need to have open the Spreadsheet Basics report template. This is where you're going to copy and paste in all of your data sheets and answer questions and things like that, and ultimately submit. And then finally, you will need the spreadsheet template open to fill in all of the answers that are answers to questions that are given to you in the Spreadsheet Basics lab manual. So let's just look at this really quickly. The Spreadsheet Basics lab manual. Of course, it has objectives, and read these lab notes. You can probably read these once and then be done with them. You might want to come back at the end of the lab to look at the lab report checklist. This gives a rough rubric of how you will be assessed at the end of this lab. And then you will go on and read the lab manual and start these activities. So let's just do some of these activities together and describe what a spreadsheet is and what it does and why we are aiming to use this in the physics labs and future labs. So spreadsheets are a series of cells, right? Each individual box rectangle here is entitled a cell. It's called a cell, and they have both a column and a row designation. So right now we're highlighting cell C4. You can also see that right here. We use these designations to make calculations, and we can use them for a bunch of different things. So let's just start off with the first activity and pick a couple of these constants, pi, Euler's number, root 2, one of these constants, fill them in as x and y, and then do all of these operations and functions, these calculations based on x and y. So I'm going to choose, why don't I choose pi? So we'll enter 3.142. And I'm going to choose, how about the square root of 2? So 1.414. Okay, so these are in cells B3 and B4, respectively. I want to use these two numbers to calculate a bunch of different things, most of which are right here, using operators. To use Excel as a calculator, you need to enter a formula. So to enter a formula, you need to press the equals key, and then we can enter in different cell references. So in this case, we have X, so I'm just going to click on X. You see it puts B3, the B3 reference in there, and I want to add to that cell B4, or whatever is in cell B4. And look at that, I have pi plus the square root of 2. I'm not exactly sure why you'd want to do that, but that's what we're doing here. We will continue doing all of these calculations. So we'll enter this formula equals x minus y equals x times y equals x divided by y. Oh, I screwed up there. I put in x instead of the cell reference. I'll just go back and correct that. This one is equal to x to the power of y. So this is putting in a slightly more complicated equation or formula, 2 times x plus y. And we have something that looks very similar but is actually different. And we'll see that in the final result. We'll say 2 times open parentheses x plus y. Let's see, these are two different numbers. In this case, we multiplied x times 2 before we added y. In this case, we added the 2 before multiplying times 2. Okay, and these are logical statements. Is x larger than y? This should be true, or yes, true. And is x less than y? This should be false. Okay, so these are all of the operations. There are other things that we can put in these formulas, and we can put in functions to these formulas or combinations of functions and operations. So let's just, I start off with kind of a special one. This is the only function that does not take an argument and is just pi. Right, so that just returns the value of pi. Now we want to take the sine of the x value, so the sine of pi. This is equal to sine of, we have to put that open parentheses there, and then the number pi. So this really should be 0. The sine of pi is 0. However, since we have some rounding here, right, pi is really 3.14159, etc., we get something that's just off of 0. So keep that in mind when you're applying functions to rounded numbers. We'll do the same thing here, is equal to cosine of pi. This should be 1, but it is just very close to 1. Now we're going to take the exponent, e, the number 2.71, we can use the function exp to find that. So this is a little bit special. I meant to put a tan 2 here. And this calculates the arctangent at the point xy. So we'll just not worry too much about what that means right now, if you don't already know. And we'll put in a tan. You see the function, both a tan and a tan 2 come up here. We're going to put a tan 2, and then the x number, and then the y number. We want y. We're assuming that y is in radians here, and we want it in degrees. So we can use the function degrees. This automatically calculates. This is an Excel function that calculates degrees from a radians angle, an angle in radians. So in that case, that is that. Now we want to calculate the natural log of x. So this is just equal to the natural log, ln, of this number. Now we want x to the power of 1/2. So this is equal to x to the power of 1 divided by 2. Okay. Now let's take the square root of x is equal to sqrt is the function, the Excel spreadsheet function for square root of the number. And we get the same value as x to the 1/2, which is the definition of the square root. So there we have learned how to use operators and functions in formulae in spreadsheets. We've also learned about cell references, and we want to demonstrate our understanding of this by copying this spreadsheet, this data table, into our report format, which we will, again, ultimately submit. So I'm going to select all of the cells that I want to copy, and you can right click and hit copy. You can hit Control C if you're on a PC, or Command C if you're on a Mac, and we will go to the spreadsheet basics. I'm going to start filling out our report template. Okay, so we'll put in a name. Let's say my name is Bilbo Baggins. Maybe I don't want that in red, so I'm going to switch that back to black. The date is 12/31/1999. The course is Physics 123-456. And the instructor, let's say we're taking this from Professor Sprinkles. It might be a dog's name, but sometimes I feel like dogs are more intelligent than humans, so we'll just run with it. Okay, so we want to take our data table and put it into our report. So we'll copy the data table in here. I'm going to show you something. I'm going to hit Control V or Command V and just paste it in there. I find this annoying because it puts it in a sort of table form that you can manipulate in Word. I'm actually going to undo that by pressing Control Z. And instead, I'm going to copy in the table, the data table, by right-clicking and pasting as a picture. What this does is it allows us to manipulate this whole table as a picture. It is much more convenient than dealing with all of the columns and rows that it automatically creates when you copy the full table. So that's what I'm going to do. I'm going to bring the questions back up just so that it's all on one page, but this is a perfectly valid table to submit for your report. You answer these questions, and then we move on to the next activity. Okay, cell formatting. In this exercise, you're asked to, this is kind of a tedious but necessary activity, to display the correct number of significant figures, just to display the information within a cell exactly how you want it. So let's take the value of pi and repeat it a bunch of times. I can easily repeat this. Here, we'll just do this from scratch. I'm going to delete both of these numbers. I'm going to put equals. This is the value of pi that we learned in the last activity. And what I'm going to do is continue. I'm going to repeat this value a bunch of different times. So I can grab on to this little handle in the bottom right hand portion of the cell and drag it down. Okay, say for whatever reason we only want the value of pi to one significant figure. What I can do is I can right click on this number, this cell, and format the cell. I'm going to go to number, and I'm going to decrease the number of decimal places to 0. Okay, so now we only have one significant figure of pi. Similarly, we'll just do this over and over again. I'm going to format number, and then we have two significant figures. I think we can also use this button. Whatever you call that button, I don't know. Oh, look at that, decrease decimal. But I tend to just do the manual thing and go to the pop out that it gives you. when you go to Format Cells. Okay, is this 5 significant figures, 4 decimal places, and the leading 3? Okay, now we want to transform this into scientific notation, and in Excel, as in many other programs, you are given this nomenclature E, which means times 10 to whatever exponent is after this. Okay, so in this case, we'll give it 6 decimal places. So 6 decimal places, so it's 3.141593 times 10 to the 0 power. And as we all know, anything to the 0th power is 1. Okay, finally we want to try and put this in dollars for whatever reason. Pi dollars. Currency. And it's in dollars. Great. Now we want to put it in British pounds, again, for whatever reason. It's also a currency. And we'll go down to, where's the pound? The English pound. There we go. Okay, so that's the formatting. There are no questions to answer for this, so we'll do the same thing by selecting the cells that we want to copy, hitting Control-C or Command-C if you're on a Mac, and copying the filled data table here. I'm going to right-click, insert the picture, and this is all you need for activity number 2. Moving on to activity number 3. Slightly more complicated. We get to plot something this time. And follow the instructions, or you can just follow my video. And we're going to go to plotting. Let's make this a little bit bigger so maybe you can see it a little bit more easily. In this exercise, it asks you to choose kind of small numbers for M and B. So let's choose 3 and 5. So in this exercise, we're going to try to implement this equation for a repeated independent variable and dependent variable. So first we need to kind of choose what the independent variable is going to be. In this case, we have started off with -10 and -9. And if we select both of those cells and then drag them down, it repeats the pattern that we set out. So similarly, if you went 0 and 0.1, let's make a prediction that the next value is going to be 0.2 and the next value is going to be 0.3. And so it just repeats whatever pattern you put in there. I'm going to select all of those, press delete, and we have generated a set of independent variable data or domain data. Now I want to apply this equation to find the range data, otherwise known as the dependent variable data. Right, the value y is dependent on the variable x. So I want to enter a formula, but we do something a little bit tricky now. We are going to, there are 2 types of cell references. There are floating cell references and fixed cell references. So to put a fixed cell reference in, we want this M. We actually want $signs in front of both the column and the row letter and number. So no matter what happens, the value of M will always stay the same. And that'll make a little bit more sense here in a second when we drag this formula down and repeat the pattern. So we want it to be times x, and the x value in this case is -10 for this particular y value, and we want to add the b value. We want to do the same thing here and fix that b value and put in dollar signs in front of the column letter and the row number. Okay, so this makes sense. We have 3 times negative 10 is 30, or sorry, negative 30, plus b, 5. Negative 30 plus 5 is in fact negative 25. Okay, so now when I drag this down, let's see what happens. Let's look at the formula that is in this next cell. So we can see from cell B8 to cell B9, B3 and B4 remain the same, but the A value changes, right? So the X value is changing while the M and B are constant. So we've sort of fixed M and B and continuously updated the value in the independent variable column. So great, let us use this domain and range to make a plot. In this course, we are almost exclusively going to be using scatter plots. So if you go to Insert, and then under these charts, we're just going to go to Scatter, and it brings up a blank interface. There are other ways to do this, but I like doing it from scratch, so that's the way I'm going to teach you to do it. Right-click on this, and go to Select Data. We want to add a series, and this is where you put in your X and Y values. I click on this arrow, I don't know if that has a name, to select the X data, enter, and then the Y data, enter, and there we go. Now we have our plot. It is a line as we expect it to be from this line in slope-intercept format, but we want to make this plot presentable for our instructor. So the first thing I'm going to do is I'm going to add a title. I'm going to just go ahead and add a title. We'll say that this is something pretty generic like scatter plot of a line. And I don't know what the horizontal and vertical axes are, so I want to add titles to both of those. To do that, in the ribbon, it brings up these 2 tabs called Design and Format. You can add a lot of the chart elements by clicking on this button, and we'll go to Axis Titles, Primary Horizontal. We'll name this. This is going to be we'll put all the names in. Domain of the independent variable X. Do a similar thing for the Y, or the vertical axis, primary vertical. Range of the dependent variable Y. Okay. I sort of find that putting the numbers in the middle are kind of annoying. So there are a lot of chart formatting options that you can see by right-clicking. You can click on a bunch of different things in the scatter plot and change the behavior of them. So I'm going to first go to the vertical axis, go to Format Axis, and I'm going to put the labels low. Okay, so that moved the numbers over there. Now we're kind of overlapping there. You can kind of move these things around. I'm going to do a similar thing to the horizontal axis. Right-click, Format Axis, Labels, Low. Okay, I think this looks a lot cleaner, a lot better. And of course, again, there are a lot of different options. For example, I could change the bounds of this to be -10 to 10. Right, and that takes up the data now take up the entire screen. I'm actually going to put those back on auto because we're going to play around with the numbers a little bit. Great. So similarly, we can copy this. Well, let's copy the data table first. Yeah, we're pretty much done with all of our exercises in this part. So I'm going to copy this data table and go over to our report template and hit Control V. Oh, I did that wrong already. I want to right click and hit Paste Picture. We are also asked to include the scatter plot. So I'm going to copy that and then paste as a picture. Okay, so something strange has kind of happened here. It seems like it doesn't all fit on one line. So there's something special that you can do with pictures that help with formatting and allow you to put these pictures anywhere you want on the page. And you can get this to happen two different ways. You can right click on this and go to wrap text. And I either like square or tight. Okay, I'm going to do the same thing here, but I'm going to do it another way. Instead of right clicking and going to wrap text, it automatically brings up this little icon, layout options, and I'll just go ahead and say this is square. Okay. Now, instead of this picture being in line with the text, now it allows text to kind of wrap around this picture. It also allows me to put these pictures right next to each other, which is kind of nice. I also like these anchors, so it shows you where the printable areas are. And there we have it. I've organized these two copied pictures in the way I think looks good. Okay, similarly, answer these questions, and then we'll go on to the final activity. Okay, so in this last activity, you are asked to plot something on your own. Make your own plot. I did the sync function, but why don't we just delete this and do everything from scratch. Okay, so I'll delete. Oh, did I do that right? I don't think I did that right. Just need to delete all of this. Hit delete and not backspace. So let's pick something simple like the sine function. A lot of people know what a sine wave looks like. So first I need to select a series of independent variable values. Let's just go from, let's do a similar thing. We'll do -10 and we'll subtract, or we'll add 0.5 for each one. So this would be -9.5. I want to continue this pattern. Whoop, I went too far. In the highlighted boxes. Oh, that goes to 30. Oh, we really only want to go to 10, right? Plus or minus 10. Okay, so let's see if we can't get something resembling a sine wave. So we're going to enter the formula or function sine of this number. And drag this down. Get all these sine values. And let's plot this and see what it's like. So I'm going to insert a plot, scatter plot, right click, select data, add a series. You can give it a name if you want, but I usually don't. Those are the x values, and the dependent variable values are here. And OK. There you go. So we have something resembling a sine wave, and you can think about how you would get more data points in here. We could make our x variable a little bit more granular instead of going from -10 to -9.5. And let's just do it real quick. We can say this is -9.8 and repeat this pattern. Now, unfortunately, we're only going to -2, so we're plotting from -10 to -2, but we have a much more well-defined sine wave. Okay, so I encourage you to think about all of the functions you've encountered or equations that you have encountered in life and do one of those. Format this how you think appropriate and copy it into your spreadsheet basics, plot a plot part, answer these questions, and then you're done. So when you're done, I'll just do this real quick. We'll say this is the sine function. We'll format this a little bit. Labels, low. Add chart elements. Where did it go? There it is. So that's just x. This is sine of x. We'll squish that a little bit so we can see that. Okay, I don't want the table, we don't want the data table in this. We just want the function. So we'll press Control-C and paste as a picture. Answer these questions. And then once you've done all of that, to submit your report, you need to go back over it before you print to PDF or save this as a PDF. Looking at the lab report checklist, and then we can save this. So I'll go to File, Save As, PDF, and maybe I'll put my name on it. So this is Baggins. Save. Now before you submit, I encourage you to now where did it go? I can find it. To open up the PDF, here it is, that we just generated, and look to make sure that everything is there. Of course, I didn't answer the questions here, but I can see the data table. Here's my second data table. Here's the scatter plot with the associated data table, and then finally the sine function. So this is what you would submit as your report for your first lab. So I hope that helps. I'm not sure that I can do this for every single lab, but I want to get you started off on the correct foot. So that's everything. I hope you had a good lab, and see you next time. Bye.